All right, what about now? These laptops don't let us watch the video. We have to use our personal email. Okay, can you guys hear me now? All right, what about now? Okay, good. All right. Let's go back then. All right. Sweet. Okay, so let me recap then. Let me go backwards. Okay, so for the CYU then, so we had two basic equations that we looked at last week. And the first one was interest, right? This is just to determine the interest.
All right, what about now?
Oh, wait, there's a feedback loop. Hold on.
This laptop's don't let us watch.
Okay. You guys might get like this weird feedback loop in about a second. But that's because I had my video playing at the same time. Okay. So once that passes, we should be back to normal. All right. So we had interest formula, then we had final value. Okay. And when we took a look at the question, it just depends on what they're asking us, right? We can decide which one we want to use. So we decided that principal was 1,000. The rate is at 1.8%. So that basically leaves us at 0.018. And then we have two different questions, and each one have a different amount of time. Okay, so if you look at A, it's asking how much interest you will have earned at the end of 9 months. Okay, and if you look at B, it's the value of the investment at the end of 6 months. Okay, so actually it asks two different questions. One is for interest, and the other one is for a future value, right? So for each A and B, it's asking us to find something differently. All right, so for part A, okay, pretty simple, right? We want how much interest you will have earned. So we start with I, right? Interest will be the principal, which is 1,000, okay, times the rate, okay. But it's at the end of 9 months, right? So if we wanted to use a time, then we would have to talk a little bit about making that conversion into months instead of years, because years is the standard unit for interest, but because it's only 9 months, then we're looking at 9 months out of 12. Okay, and so therefore drop that conversion down to 3/4. So then we can utilize 3/4 as our time to substitute, right? So we get 1,000 times 0.018 times 3/4. Okay, and so then that'll help us find out the interest earned in the 9 months at 1.8% with a $1,000 investment. All right, so real quick, let me just pop out my calculator here. So 1,000 times 0.018. Oh, wait a second. I forgot to hit times. So 1,000 times 0.018. Right? And then times, now we have our fraction here, which is 3/4. Okay, so ultimately the interest that's earned is $13.50. Okay. All right. Any questions there? How we doing? Okay, so let's move on then. And let's take a look at part B. So for part B, the final value, we got to use the other formula. So we're looking at F is equal to P times 1 plus the rate times the time. Okay. And so now we're looking just to find what is the future value of the investment at the end of 6 months. Okay. So again, very similar. We still have the same principal, which is $1,000. Then it's 1 plus the rate. The rate in this case has to be in the shape of a decimal. So you have to utilize 0.018. Okay, and then when it comes to time, then we have to talk a little bit about how we make this conversion, because it's 6 months, not in terms of years. Okay, so for time, 6 months out of 12 months, well, that's the same as 1/2. Okay, so our value for time is represented by 1/2. Okay, so now to find the final value, we just go ahead and multiply it all together. So let's go ahead and do that. All right, so let's clear. Got 1,000 times 1 plus, one more, 1,000 times 1 plus 0.018 times 1/2 is the same as 0.5, so I'm going to keep it with decimals this time. And so we end up with a value of $1,009. Okay. All right. So there it is. A little bit of a quick recap. All right. So now part C then adds another level of complexity, but basically the whole point of part C is to try to show you that simple interest, regardless of whether if the interest is paid at the end of the term, so let's say at the end of 9 months or at the end of 6 months or at the end of a year, or if it's paid quarterly, the whole point of part C is to show you that there is no difference when the interest payments are made onto the principal, meaning that the final value that you will get will be the same if the payments are made in shorter amounts of time or if it's at the very end. Okay, and so that's essentially what part C is about. So it wants us now to go through parts A and parts B on her initial investment and the same annual interest, but what if the interest was paid quarterly? Okay, well, let's take a look at that. So starting with whatever information we had in A, right? So in A, they were saying that she was going to earn interest at the end of 9 months, okay? But the interest was going to be paid quarterly. So remember when we talked about quarterly, you're basically splitting up the year into 4, right? So you have your 12 months of the year, you divide that by 4. So really what we're talking about is a period of 3 months. Or a 3-month period, right? And so if, for example, we are doing the same calculation with the same investment that she has, okay, and we're trying to find out how much interest she will earn at the end of those 9 months, but instead of getting one payment 9 months later, we basically break it up into, well, what if she gets a payment after 3 months, then another payment after 3 months, then another payment after 3 months? Like, what would the final interest be? Okay, and so here's essentially what we would have to change about our setup. Since we're looking for interest, we still start with the $1,000 principal. Okay, now the rate that we're given is an annual rate. Okay, so for us to say, if I were to go back up here, this is the annual rate, not the quarterly rate, right? It's not the quarterly rate, that's for the entire year. So if I want to know what my rate would be quarterly, I would essentially have to divide my rate by 4. All right, so then I would take this rate, and that's the rate that I'm getting for every 3-month period, right? 0.018 for the whole year, but every 3 months, it's only a quarter of that. Okay, so then the time represents how many periods of 3 months exist in our situation, right? So because she's going to have to earn at the end of 9 months, well, how many 3-month periods would that be to get us to 9 months, right? And so, well, 3 months, then another 3 months, then another 3 months, right? So in total, we had 3 of those periods, right? 3-month periods, okay? And notice how what we ended up building right now is exactly the same thing as what we had when we did it the first time, right? Except that right now the 4 is in the denominator for the 0.018, but because it's multiplication, it's going to end up being the same thing anyway. So eventually, right, if we do this calculation, right, I could start with the 0.018, divide that by 4. So that's my interest for 3 months, right? Not a full year. That's how much interest I'm going to earn just in those 3 months. Okay. But then I'm going to have 3-month periods, right? So then that's where I multiply by 3. And then I multiply that times my final principal, right? Or my initial principal, which is $1,000. And notice how the interest still ends up being the same thing, which is $1,350. Whoa, sorry, wrong thing. Okay. So the only difference is that now if it's done quarterly, it just means that after the 3 months, I'm going to get a payment. Then another 3 months, I get another payment. Then another 3 months, I get another payment. Versus waiting an entire 9 months and then getting my payment at the very end, right? But notice how with simple interest, there's no benefit to either getting paid after 9 months or getting 3 payments every 3 months. You're still going to end up with the same amount of interest regardless. Okay? And this is where it's going to change when we start to look at compound interest. We're going to see how it's actually beneficial to use compound rather than simple. Okay, because with compound, it actually makes a difference when you get things compounded quarterly versus if you wait for the whole year. All right. And then the same idea applies for the future value of an investment at the end of 6 months. Okay, so if we were doing it for the other scenario, okay, again, it's like quarterly. So again, it's 12 months. You'd have split the year up into 4. So now you end up again with 3-month periods. Okay. Final value now. We know it's $1,000 principal. We have 1 plus. And then we know rate is coming and then time. And so these are the ones that now we have to think a little bit about. So we're splitting up the year into quarterly, right? So again, I have to take that interest and divide it by 4. Now this time, because it's only 6 months, I have to think about, well, how many 3-month periods are there in 6 months? Well, it's 3 months, then another 3 months. So because there's only 2 of them, that represents my T. And that's my time. Okay? So multiplied by 2 for my T. And now I can do the calculation. So notice again, it's going to represent, it's essentially the same thing that we have here, right? If I were to take that 2 and that 4, and if I were to simplify those out, well, that ends up being just 1/2, right? It's the same. Okay, so again, we can just kind of go through the calculation here, work our way from the inside out. So I want to start with the 0.018 divided by 4. So let's clear. This time, right? So again, remember, it's the same interest now. The 0.045, that's the interest that we get for a 3-month period. Okay, now since it's 6 months, that's 2 3-month periods, so I multiply this by 2. Okay, so that means that in a total of 6 months, I'm actually earning 0.009, which makes sense because that's half of 0.018. And then I multiply that times, oh, I'm sorry, before I multiply that, sorry, we're going to add that plus a 1, okay? And then we can multiply by 1,000. Okay. So again, my final value in this case is going to be $1,009. Okay, same value that we got when we did it the first time. So quarterly just tells you how they're going to split it up over the course of a year. But it doesn't make a difference in how much money you get. At least not with simple interest. Okay, remember that this is a simple interest. So let's make a note here that with simple interest, there is no difference with interest earned. Okay, meaning that there's no benefit, right? There's no difference with the amount of interest that you earn by getting paid or by getting interest paid quarterly or annually. Okay. So if you're a little impatient, right, and you do want to see something in your account, then I guess it makes a difference, but ultimately it doesn't, right? Whether you wait 6 months or you wait a year, I'm sorry, if you wait 3 months or you wait 9 months for part A, right? No difference. If you wait 6 months versus wait 3 months, you're not going to see a difference at the end, right? It's still the same. All right. All right, cool. Then let's go ahead and move on. So like I said, there's a little bit of a lag with when I finish speaking, and then when it actually streams. There's about 15-20 seconds or so. So if you do have a question, even though I'm done with that topic, go ahead and ask it on the chat, and I can always go back. All right, even if I see it later, like I'll stop and then I'll go back to clarify anything. If you tuned in a little late, feel free to just start the video from the beginning, and just kind of work your way through it as you go. No big deal. All right. Okay, so I'm going to go ahead and move on. I'm going to move on to the beginning of the next investigation. Okay, so this was the investigation number 1, just finishing up the CYU. So next section, okay, is the compound interest investments. Okay, and so basically, compound interest, to summarize, is the most beneficial to you. It's the most beneficial to the banks when they charge you interest via credit cards. Most of the time, whenever you take out a loan, the interest type that you will be given is a compound interest. Very rarely will you find a credit card company that says that you will be able to pay things back using simple interest. Okay, you're more likely to get simple interest when you put money in your bank in a savings, such as like the CD account, because they don't pay you as much, and so you'll see the difference today after we do a couple problems. However, when they charge you interest, then they charge you with compound, because you're basically, that's how you end up paying interest on top of interest. Okay, and so you'll see how that makes a little more sense as we go. All right, so just real quick, so unlike in the case of a simple interest investment, in a compound interest investment, the interest for each period is added to the principal before interest is calculated for the next period. All right, the interest rate per period is the annual percentage rate, APR. Okay, so you may have seen this term APR when you're watching commercials and you see something, with a car, 0% APR, 1.9% APR. That's basically telling you the annual percentage rate, okay, divided by the number of interest periods per year. All right. Banks usually use 360 days as an equivalent of a year. So throughout this unit, you should use 360 days as an equivalent of a year and 30 days as the equivalent of a month. So as you work on the problems on the investigation, look for answers to this question. How can you determine effective annual interest rates, balances, and yields of investment involving compound interest? Okay, so just a couple of things. Compound interest, and just in terms of how things are labeled. So typically, compound interest introduces this new variable. From simple interest, there's going to be some carryover, right? You have interest earned is principal times rate times time. Okay. With compound, it's a different formula, which I'm not going to give to you yet, because part of the first few problems is they want us to kind of figure it out on our own. But by the end of today, I'll definitely show you what it looks like. So with compound interest, there is something new, which is essentially the number of times that things get compounded. And so you're introduced with this new variable called n, right? N is not principal, n is not the rate, n is not time. N is the amount of times that the interest is compounded, all right? And so it's very similar to what we looked at before, where if it was quarterly, you had to divide it by 4. And so there's different terms that determine different things. So basically there's a guide here that if something is compounded annually, then your n is going to be 1. If something is compounded semi-annually, right, that means 2. Semi is twice a year, right? Sometimes you hear that on commercials. Semi-annual sale, right? That means that they have it like twice a year, maybe once in the winter, once in the summer. Okay, then, right, you've seen this one before. This is quarterly. So if something is being compounded quarterly, then that means 4 times a year, right? They broke up the year into 4 parts. Then there's monthly. Right, so if something happens monthly, well, that means it happens 12 times a year. Then there's daily. Actually, not daily. Before daily, there's weekly. And if you're not sure, well, there's 52 weeks in a year. And then finally, there is daily. Okay, now we know that typically it's about, typically it's 365 days a year, 366 with a leap year. But for them, they're going to consider, the banks consider daily, they go to 360. Okay, and so that's because they're only counting 30 days in a cycle. So whenever you get a statement, you get a bill from the bank, it's every 30 days. So if, for example, you have 31 days in a month, then you're just going to have to pay your bill like 1 day earlier. Okay, and that's all. All right, so compound interest introduces this new variable, and then there's a reason why. Okay, so we'll keep that in mind. We're not going to use it right away, but it's going to be useful a little bit later. All right, so Just one of the big differences. All right, so now number one, so it's asking us, suppose that you're considering making an initial deposit of $1,500 in a 5-year CD. Interest is paid at an APR of 4%. Okay, now so far, right, from what we've read, it doesn't indicate whether that APR is interest, simple interest, or if it's compound interest. Okay, but the key word typically pops up. And so here you see it, that you have 3 different plans, right? So you want to find out which plan is going to be the most effective for your investment. All right, so plan 1 is telling you that you're going to compound this at semi-annually, right? So first of all, it's telling you it's compounded. So that's your hint that you're going to use compound interest instead of simple interest. You have to really read carefully, because when you look later on at the problems, and they're not going to tell you if it's compound interest or simple interest, you're going to have to figure it out by reading. And one of the key clues is, if it's telling you that it's compounded, like it is in all 3 of these, then it's compound interest. That's the easiest way to know. If it's simple interest, then it'll tell you very specifically that it's simple interest. Okay, just like it did before, right? If you take a look at the CYU, it said that there was a simple annual interest, right? And so that's how you know which one to use. All right, so we know we're in the compound interest frame of mind. All right, then it's telling us we have 3 different plans. All right, so just imagine you walk into the bank and they tell you, you tell them, I want a CD account, I have $1,500 to deposit, and it says that you guys offer an APR of 4%. Then the bank tells you, sure, you can compound it at semi-annually, you can compound it quarterly, or you can compound it monthly. Now, if it was simple interest, it wouldn't matter which one you chose. If it was simple interest, semi-annually or quarterly or monthly, it wouldn't matter, because the amount of interest you earned would have been fixed. You would have got the same amount whether you chose to do it semi-annually, quarterly, or monthly. But now you're doing compound interest, okay? So it works a little differently. So let's say you choose to do it semi-annually, right? You're going to do this semi-annually for just 1 year, okay? So for part A, it says to calculate and compare the values of the 3 investment plans after 1 year, then after 2 years, and then after 5 years. Okay, so we got to set up like a little bit of a table here. All right, so we got plan 1. We got plan 2. And then we got plan 3. All right, and then across the top, we're going to go with what is the value of your investment, right? The value of the investment plans after 1 year. So we're going to go with 1 year. After 2 years. And then after 5 years. Okay, plan 1 is to compound semi-annually. That means you're only doing it twice a year. Plan 2 is quarterly. So that means it's going to be compounded 4 times a year. And then plan 3 is monthly. All right, so the idea here is just to see what are the comparisons in how your money will grow depending on the choice that you've made, whether you want things to be done semi-annually, quarterly, or monthly. All right, so first of all, let's start off with, all right, let's do the math here for 1 year if we're doing semi-annual. Okay, so how is that going to look like? Okay, well, you know, you start with $1,500. Or maybe I'll do it in here. Okay, and then we got to use a little bit of what we looked at in the CYU almost. All right, so it's an APR, annual percentage rate. So annual percentage rate was 4%. Okay, that's for the whole year, right? That's for the whole year. However, if it's going to be done semi-annually, then what do you think you're going to have to do with that interest rate? You're going to have to split it in half, right? Semi-annual, twice a year. So you're going to take that percentage, you're going to cut that in half, all right? So really, you're looking at 2%, okay? So that means it's basically a 2% that you've earned the first time it's done, okay? So we're looking at this semi-annually, so I'm going to kind of break it up into a timeline. So here's when you initially invest $1,500. Okay, then here's the 6-month mark, and then we'll do the 1 year. All right, well, I want to know how much interest I've earned after the first 6 months. Okay, well, it's 2%. It's a 2% interest gain. Okay, so then I can use my basic interest formula here just for one time. I know that it's going to be 1,500 times 2% is actually 0.02. All right, so 1,500 times 0.02, cool, that's 30. All right, so then that means that after 6 months, now what I have a payment of $30 in my account. Okay, and then it's done one more time. Okay, because right now, since it's semi-annually, it just means that it's done at half of the year and then again at the full year. It's done twice. However, now my new balance is 1,530, not 1,500. So this is why compound interest is a little bit better, because after the first payment, then they start giving you more interest on what you currently have, not what you started with. So now here's what they do. They take 1,530, this is how compound interest works, and then it multiplies by 0.02. Okay, now 2% of 1,530 is going to be bigger than 2% of 1,500. Okay, naturally, right? It's like 10% of 100 versus 10% of 1,000. Okay, the bigger number, you're going to get a little bit more from it. All right, so then now to find out what they're going to pay you on that second, right, the second half of the semi-annual, now here's what you get. You get the 1,530 times 0.02. Oh, wait. Okay, now you got up $30.60. Okay, so I mean, it's not much, right? In this case, it's only 60 more cents, but hey, it's better than nothing, right? So then, what did you really end up with? Well, since at 6 months you had 1,530, and then 2% of 1,530 was 30.6. Now at the end of the year, you get to add and so you end up with 1,560.6. All right. So after 1 year at semi-annually, you finish with 1,560.6. Or, I mean, 60 cents. Alright, so it's basically just adding up the interest, and then you get to use that to your benefit. Right? So you start with 1,500, you earn 2% in the first 6 months. The reason why it's at 6 months is because it's semi-annual, so it's only done twice a year. You get your first 2% paycheck, gets dumped into your account, so it bumps you up to 1,530 at 6 months. Then by the time 6 months moves over to a year, then they do it one more time, another 2%, but this time it's 2% of 1,530 instead of 2% of 1,500. Therefore you get a little bit more, right? The first time you got interest, it was a $30 payment. The second time you got interest payment, it was $30.60. Okay, not much, but it's still more. So then you get to add that interest back onto whatever you had, and then you end up with 1560.6, or right, 60 cents, right, same thing. All right, now how would that have worked, or how does that differ from what you would do if it was quarterly? Okay, well, if it's quarterly, well, you got to set up the timeline a little differently, and you got to break up the APR differently as well, right? Because the annual interest is 4%. However, you're going to break it up into 4 parts, right? So because in this case the end value is 4, just like in semi-annual the end value was 2, here you're going to take this and you're going to break that up into 4. So really it's just a 1% gain every 1/4 of the year. Okay, so now I have to have a new timeline. If I'm starting at 1500 this time, well, I need to break it up into 4 parts. So now I have my 3-month mark, I have my 6-month mark, I have my 9-month mark, and then I have my 12-month mark, or my 1 year. Okay, this is the 1 year. Okay, so at 3 months, right, same idea. I have $1,500, and this time I'm getting a 1% payment, right? So it's only 0.01. Well, run the math. We got 1,500 times 0.01. Okay, it's only $15. So after 1 month, after 1 3-month period, you get to add the 15. So at 3 months, what you have in your account is 1515. Now you do it again, right? Second quarter, right? From 3 month to 6 month. But now what you're doing is you're taking 1515 and you're gonna multiply 0.01. Okay. By doing so, let's see what we get. 1515 times 0.01. All right, well now this time, this is what I got. I got a interest payment of $15.15. Okay, so I get to add that onto my 3 month. Okay, so now I'm going into my 6 month, right? At 6 months, here's what I'm looking at. I got 1530 with 15 cents. Right, so far it's been done twice. Now we're going into how much am I gonna get when I get to 9 months? Well, I do the same calculation. It's 1530.15, right? That's my current balance, and then I get 1% of that. So now 1530.15 times 0.01. Okay, so now at this point, this is my payment. I'm gonna get $15, and I'm gonna use the full 4 digits there, so 3015. Okay, I don't want to lose anything because eventually it all adds up. If I start rounding too soon, then I'm gonna lose some values that are important, and then by the end of the year, I'm not really gonna see what the benefit of compounding quarterly is really gonna be. Okay, so let's just add this up here. So we have 1531.5. That's what I earned in interest, and I add that back to what was my balance at the 6 months, which was 1530.15. Okay, so going into 9 months, now I have this balance that's 1545.4515. Okay, obviously if we were to round that we're looking at like 1545.46. Okay, and then finally, right, one more time. I've only done it 3 times, so now I got to get to 12-month mark. I got to take this value, 1545.4515, and then I have to multiply times that final percent. Okay, and so now it's probably going to get ugly from here. 1545.4515 times 0.01, and we get this really long value, right? So it's 1545.4515. All right, so now we're gonna add these two values right here. This is my current balance, and this was the interest I earned between 9 months and 12 months. Okay, this is the final payment, and so then whatever we get when we add these two sums, that's gonna tell us how much money we get if we would have waited a full year, but every 3 months they were tacking on some of my interest. Okay, so let's see how that works. So finally, 1545.4515 plus 15.454515. All right. So now, okay, here's my final value. Okay, this one, now that I'm done, this is the one I can round. I just don't want to round anything before that. Okay, because then I lose characters, I'd lose money basically. Okay, so you want to try to keep as many digits as you can, so that when you're doing that 1%, right, even though it's pennies, you're still racking up some pennies, and eventually it's going to make a difference, right, as time goes on. So we get 1560. Let me do this in a different color actually. 1560 points, and this time it's 906. Okay, so I want you to compare the value that we got after 12 months when we did quarterly versus after 12 months when we did it semi-annually. Right now your total is 1560.91, right? We can round it now. Okay, 0.906, it rounds to 0.91. Okay, so what was the benefit of compounding quarterly versus semi-annually? It wasn't much, but it was a 31-cent gain. Right, those pennies were adding up, and so ultimately you ended up with 31 more cents in your account by doing it quarterly than if you would have done it semi-annually. Right, so again, not much, doesn't really seem like significant. But what if it was a $15 million investment versus a $1,500 investment? Right, that's when it matters, right? When the values, when the investments, yeah, more money, exactly. When the investments are larger, those payouts make a difference, right? Because then instead of pennies, it's 10, 20, 30, 40, $50, right? It's actual something that's worthwhile. All right. And so you can imagine, right, what it would look like if we did it monthly. Okay, now I'm not going to do it monthly because it gets really ugly. I don't want to have to do this 12 times. All right, so then now this is where the shortcuts start to come in. All right, this is where shortcuts start to come in. And so we're going to skip the rest of this for now. Okay, because now you kind of have an idea. Look at all of the different options that we had before. Semi-annually, quarterly, monthly, weekly, and daily. Right? The more times it gets compounded, more money, right? So you should expect monthly to be larger than quarterly, right? Because here, how many times is it done in a year? It's done 12. If you do it 52 times, or if you do it 360 times, you're going to see those pennies start to move. You're going to see some benefits in that. Okay. All right. So I'm going to come back to this table, but we're not going to do it the way that I have been doing it so far, because I want to transition and take a look at what the formula looks like. Okay, so once we have that formula, it's so powerful, right? And so then we can just use it instead of relying on like this basic kind of calculation stuff. All right. Okay, so we're temporarily skipping B for now. We're temporarily going to skip C. And we're gonna skip number 2. So let's go down to number 3. Okay, and number 3 is asking to write a formula that gives a future value. Okay. Or actually, hold on. Let's go back to number 2. I don't want to skip number 2. Sorry. Let's do number 2. Right, so for number 2, for each condition in problem 1, write a formula. F equals, that would give the value of the above investment after T years. Okay, well, let's think about what we did. Okay. If I have a future value that I was looking for, okay, after T number of years, well, the amount of years that we only did it for was just 1 year. Okay, so I know that my T is going to be 1. But let's think about what we did, right? We took a principal amount of $1,500. That's what we started with. And then we multiplied that $1,500 by something. Okay, now because I want to find a final value, I have to treat it a little bit differently, because if I just use what I have here, it's just going to give me the interest that I earned. And because it's F, right, we want a final value. So I know that I need a 0.2 in here somewhere. Right? This is for the plan of a semi-annual plan. Right? So my rate, rather than it being 4%, it got slashed. We had to cut it into 2 parts, so it became 0.02 at 2%. And very similar to what the final value for a simple interest is, there's a 1 plus. Okay, there's a 1 plus in here. Okay, why do you think that is? Okay. If you notice that if you multiply something by just 0.02, that tells you how much interest you've earned. Okay? But then what did we always have to do with that interest earned? You had to go back and add it to your original, right? So think about what this is saying, right? A final value in this case, if it's done once, well, it would give you, right, when you distribute 1,500 plus, well, when you multiply 1,500 times 0.02, that's where the 30 comes from. So you end up with a final value of 1,530, right? That's why we need the 1 plus. If I didn't have the 1 plus and I just had the 0.02, I would only be getting this number. And that tells me interest, but not my final value, okay? Now, I'm not done here, because this only works one time around, right? How many times did we have to multiply by the 0.2? Essentially, we had to do it twice, right? We did it once after 6 months, and then from 6 months to a year, we had to do it again, all right? And in the meantime, right, the initial changed. Okay. So how would that look like if I really wanted a formula that would then eventually take me to this value, right? Without me having to do multiple steps. Like I just want one formula that tells me, take it from 1,500, multiply it by something, and get your final. Well, if I want to know that, well, since I multiplied by 0.02 twice, I would have had to have squared it. Okay, and so it kind of breaks it up into how we end up with $1,500 investment and end up at 1,560. Okay. Another way to look at it would be, all right, I have a final value. I have a $1,500 investment. Okay, I have 1 plus, well, I have to take my percent, which is 0.04. Because it's semi-annual, I have to cut that in two. And then because it's semi-annual, right, it's semi-annual, it has to be done twice. Okay, so this would have worked right here. This equation that we got initially, this works for just 1 year. Right, but then if you look at the table up here, well, it gives us options of 2 years and then of 5 years. So how does that then change the formula? Well, because now we have multiple years, now I have to introduce this formula, a t, right? Because if you have to do it twice for 1 year, how many times do you have to do it for 2 years? Well, you'd have to do it 4 times. If it was 10 years, then you'd have to do it 10 times, right? So then the t takes care of that, because you could plug in the amount of years in which it has to be done, and ultimately that gives you how many times you would have to take this to that exponent. All right, so that's what works for plan 1, right? So this is plan 1. All right, now let's take a look at plan 2. Okay, if it was plan 2, same idea. F equals, they all started with 1,500. Okay, 1 plus, but in this case, right, what was the percent that we were multiplying by? It was 0.01, right? So it's 0.01. And how many times did I have to do it in 1 year? I had to do it 4 times, right? So then how can I adjust it to account for multiple years? Well, now it's F equal to 1,500 times 1 plus the original rate, remember, was 0.04. Because we were doing this quarterly, I had to divide that by 4. Okay, so basically that's how I get the 0.01. All right, so they're the same thing, they're equivalent, just written in different ways. It's 4 times in a year, but if I have multiple years, then I would need a variable of t. Okay, so that if it was 2 years, it's 4 times the first year, 4 times the second year, and then that's how it ultimately, it would have had to have happened 8 times. Okay, but you can see how tedious that would be if we had to continue this, 15 months, 18 months, 21 months, 24 months, and you were getting decimals that were already pretty extensive. Okay, so then the t here as part of the exponent, 4 times t, but that is a power of what you get for whatever's on the inside. That helps take care of having to do it to that amount of times. All right, and then the last one, right? We can basically build this without really having to do it the long way, right? So for plan 3, if I want a final value, I can take $1,500. It's still 1 plus. Okay, now here, remember it was 4%, so that's 0.04. But how many times do I have to do it if it's a monthly plan? Well, it's got to be 12. So I have to take that percent and divide it by 12. If I need to do it 12 times in a year, then this is going to go up to, right, the power of 12. Okay? And in order for me to be able to account for multiple years, because to the 12th power right now is only 1 year, then in order for it to be something I can use for a certain amount of years, right? If I want to find out how much it's going to be after 5 years, then I can go ahead and write it as 1,500 1 plus 0.04 divided by 12 to the 12 times t power. Okay, and then this represents plan 3. So now I can find out what the monthly plan is, or after, let's say I want to know how much interest or what my final value will be after 1 year if I compounded monthly. I can do it now, right? I can just go ahead and actually calculate that. without having to do this 12 times, right? And so let's go ahead and do that, and let's fill in the rest of the table using the formulas that we found. Okay, so let's go ahead and find monthly for year 1. Okay, so I want to know what fits here. So we can go ahead and use that formula. Okay, it was F equal to 1500 times my annual rate, or 1 plus my annual rate of 0.04 divided by 12. But because I have to do this 12 times, right, it's to the 12th power. All right, so now that final value, let's go ahead and do it. So remember, when you're doing this, work from the inside out. Start with the fraction 0.04, divide that by 12. Okay, do not round at this point. Okay, do not round it. Once you have that decimal, then you add 1. Okay, now you take that value, you're going to take that value to the 12th power. Okay, and then you can multiply by the 1500. Okay, and then you can round at the very end. Okay, so now this number that we have right here, 1,561 and 11 cents. Okay, that's what we can round it to. 1,561 and 11 cents. Okay. And that's what we had predicted. We had predicted something like this before, where we had said that the more times you're going to compound something in a year, you're going to start adding up some of those pennies that you thought may have been irrelevant, right? You keep adding those pennies, and now you actually have, right, 1561. Okay, so it's only 20 more cents. Let me get a color here. It's only 20 more cents from here to here. But again, it's about, actually no, it's $1.20. What am I saying? No, wait. 90, 20 cents. It'd be $1.11. Yeah, it's $1.20. You're right. No. Why can't I do this math right now? Yeah, it is 20 cents. I don't know what's going on with me. 20 cents. Okay, and so there we have it, right? So now if we wanted to do this for 2 years or for 5 years, now we have formulas, right? Now we have formulas in place that can help us do this for us rather than having to go through this really long process, right? And so this is essentially how compound interest works. And so the more times it's done, you're just getting a little bit more interest added on to your balance, right? Every 2 months, every 3 months, every 1 month. Okay, and so now let's go ahead and calculate for the 2 years, right? So we can go down to the formula, right, for plan 1. This time, because the time is not 1 year, it's 2 years, the only difference is you're going to plug in it to, right, into that formula. Okay, so we end up with 1500 times 1 plus 0.04 divided by 2 times 2 to the second power. I'm sorry, to the second power, but because it's 2 years, now we plug in a 2 there as well. Okay, so really it's actually to the 4th power. Alright, so start from the inside, 0.04 divided by 2, add 1. Take that to the power. Well, the power on the outside is 2 times 2, so really it's to the 4th power. And then multiply that times 1500. Okay, so what we get is 1623 with, we're gonna round that up to 0.65. All right, next one, this formula here, what you would get, it would be 1-to-1 for plan 2. Okay, so for plan 2, our formula is we take 0.04 divided by 4, and then it's to the 4t power. Okay, so that a little different. 1500 1 plus 0.04 divided by 4 to the 4t power. Okay, so again, let's work our way from the inside. In this case, t is not going to be t is actually going to be 2. So start from the inside, 0.04 divided by 4. You add 1. You're going to take this now to the power on the outside. 4 times 2, that's 8. Okay, so to the 8th power, and now you multiply that times 1500. Okay, so what's the difference here? Well, you're going to get 1624, and then we're going to round that up to 0.29. Okay, so 1624. 0.29. Okay. Okay, so a little bit of a difference there, right? Versus annual, semi-annual versus quarterly, right? That's what you should expect, right? If you make the comparison between this value with this value, you should always expect that the one that gets compounded more often per year is going to be the one that gives you a bigger, a larger return back. All right, and then finally, if we do it monthly, okay, so now if we do it monthly, the formula here is going to be 1500 times 1 plus, you have your interest rate annually, but because you're doing it monthly, you divide that by 12 to the 12 times t. Okay. In this case, t is 2 because we have 2 years, so we're going to go ahead and multiply this by 2. And now let's calculate and see what we get. Alright, so I'm going to go ahead and close this. Let's see, we got, start from the inside, 0.04 divided by 12. Remember not to round this, okay? So now you add 1. Then you're going to take this to the power that's on the outside, 12 times 2, so that's 24. Alright, and then you multiply this by the 1500. Okay. So now you end up with a final total of 1624 and 71 cents. Okay, we're going to leave that one at 0.71, 1624. Okay, so again, you compare what you got versus the ones before it, right? So there should be an increase when you do things quarterly versus semi-annually, and there should be an increase when you do things monthly compared to quarterly, right? Again, it's not much, it's pennies, it's just a few cents, but it all adds up, right? So if you're going to put money into account and not do anything, you know, it doesn't hurt to have a little extra change thrown in there as well. Alright, so I'm gonna stop here. I'm gonna give you the chance to just finish up that table for the years, for 5 years, right? The only difference now is that instead of plugging in 2 for the power, right? So for this, that's the only thing that changes, right? You're not gonna change this value here. You're only changing the time. Okay. So I'll kind of just stop it about here. Give you a chance to just ask me any questions, anything that you need me to clarify, and then we'll keep going on Thursday. So I know I went a little bit over time. I know I had to figure out like the audio issue, so that took up some time. You guys can go ahead and send me a thumbs up emoji if everything's good. Speaking of numbers, can I have yours? Which number? Phone number? Luis's face. Alright. So are we okay? Any further questions? We're good? Okay, I see Luis. 2 brown thumbs up. That's a good sign. Alright. Alright. Well, I'm gonna go ahead and fake. No, you're not fake. Alright, I'm gonna go ahead and log off now. So if any questions come up, feel free to just message me. Thanks for tuning in. I hope you guys are well. I gotta log off because I gotta start a live stream for my Algebra 2 kids in a few minutes. So I'm gonna take a little break, and then I'll see you guys on Thursday, same time, 9 a.m. Now I know to turn on my microphone. So I won't take as long getting it started, okay? And then we'll finish up the rest. And once we have these formulas, like it's this unit is like a piece of cake. It's just a lot of it's just like plug it in, okay? Can you go to the bathroom? Yeah, ask your parents. I don't know. All right, guys. I'll catch you guys later. Have a good day. And if you're hanging out for second period, I'll start at about 10:30. Okay, so just hang tight and get something to eat, get some breakfast or something. Okay. All right. See you guys soon. Take care.